Yes, good day, our able listeners and viewers. Welcome to yet another lesson on the mathematics. Of course, the lesson is on the primary school level. In this lesson, we are going to discuss word problem involving fractions. If you're following the program, you have done fractions. We've done almost 3 lessons on fraction. And the last one that we did was on the addition and subtraction of fractions. So before we move to our lesson proper, we are going to have a quick revision on what we have done on the addition and subtraction of fractions. So this was an assignment that was given to you, and you were asked to try it at home. Of course, before we move to the lesson proper, we'll have to deal with it and then proceed to our proceedings today. Looking at the first section, we are given a fraction 3/4, that is 3/4 minus 1/4. We said the rule on the subtracting or adding fractions of the same denominator, hence the denominators are the same. We just add or subtract the numerators. So that is exactly what we are going to do. Starting from the first one. The first one, we have 3/4 minus 1/4. This is going to give us, hence we are taking the difference of the numerators, that is 3 minus 1 all over 4. 3 minus 1 all over 4. And this will simply give us, 3 minus 1 will give us 2 all over 4. So when we take the difference of 3 all over 4 minus 1 all over 4, the answer is going to give us 2 all over 4. That is for the first one. Then the second one, we have 3/5, that is 3 all over 5, minus 2/5, that is 2 all over 5. Again, if you observe that the denominators are the same, we just take the difference of the numerators. The denominators are both 5 and 5. So this is going to give us 3 minus 2 all over 5. I hope you do understand why we are taking one of the denominators. It has been buttressed in the previous lesson. So 3 minus 2 will give us 1 and bring our denominator, which is 5. So if you take the difference between these two fractions, that is 3/5 minus 2/5, the answer is going to give you 1/5. From there, we move to the third one. Let us see. Let us see, we have 7/8 minus 4/8. That is 7 all over 8 minus 4 all over 8. Again, the denominators are the same. We subtract the numerators. So we are going to have 7 minus 4 all over 8. If you take the difference of the numerator, that is 7 minus 4, you just take one denominator and then you proceed with it. So 7 minus 4 will give us 3 all over 8. So when you take the difference between 7 all over 8 minus 4 all over 8, the answer will give us 3 all over 8. Then letter D, we have 2/6, that is 2 all over 6, minus 1/6, that is 1 all over 6. Again, if you observe, the denominators are the same. They both have the same denominator. So the rule is you take the difference of the numerator, that is you subtract the numerators and further simplify. That is going to give us 2 minus 1 all over 6. And 2 minus 1 is going to give us 1 all over 6. So if we have 2 all over 6 minus 1 all over 6, the answer will give us 1 all over 6. Then E, we have 5 all over 7, that is letter E. We have 5 all over 7 minus 3 all over 7. We are asked to take the difference of 5 all over 7 minus 3 all over 7. Again, like the others, if you observe, they have the same denominator. So we are going to subtract the numerators. That is simply going to give us 5 minus 3 all over 7. 5 minus 3 all over 7. 5 minus 3 is equal to 2 all over 7. So when we take the difference, that is when you subtract 5 all over 7 minus 3 all over 7, the answer will give us 2 all all over 7. Then the last one, which is letter F, we have 8 all over 13 minus 5 all over 13. Again, just like the way we answered the previous questions, we look at the denominator and realize that the denominators are the same. Then we are going to subtract the numerators. So in doing so, we are going to have 8 minus 5 all over 13. Because the two fractions have the same denominator, so you're going to maintain one denominator. So if you take the difference between 8 and 5, that is 8 minus 5, 8 minus 5 will give us 3 all over 13. So therefore, if you take the difference between the two fractions, 8 all over 13 and 5 all over 13, the answer will give us 3 all over 13. That is all for what you've done in the previous lesson. Now we move on to the lesson proper. So as I said earlier, we are going to see how we apply the concept of fractions in real life situations. We are going to have problems that are going to be solved using fractions. That is word problem on the fractions. In this problem, we have a class A, that is class A, has 15 all over 19 of its students buying school lunch. Maybe at a certain school there is lunch sold there, and 15 out of the 19 students of the school are buying school lunch. Class B in another class in the same school has 13 all over 19, that is 13 out of the 19 students buying lunch at school. So here we have two classes. The first class has 15 out of the 19 students buying lunch at school, and the second class has 13 out of the 19 students buying lunch at school. So now the question is, what we are asked to find is, which classroom has the largest fraction of students buying the lunch? Which classroom out of the two classes, that is class A and class B, has the largest fraction, that is the largest number of students buying lunch at school? We are going to compare the two. We have the option A is class A, which has 15 all over 19. That is 15 students out of the 19 students in classroom A. And B is saying classroom B is 13 out of the 19 students in classroom B. So let's look at the two fractions. The two fractions that we have is 15 out of the 19, and we have 13 out of the 19. Both classes have the same number of students. But in class A, 15 students buy lunch at school out of the 19 students. And in classroom B, 13 students buy the lunch at school out of the 19 students. So you've done in your previous lesson on fractions, comparing fractions. So you will realize that hence the denominators are the same. We look at the numerators. The one with the higher number is the one that is greater. So obviously, judging from that perspective, we realize that the one that has 15 out of 19 has the highest number of students buying lunch at school. And if you look at the options that we have, classroom A is the one that qualifies for that. We'll have classroom A as our answer. All right, we look at the other question that is available for us here. We have a whole is divided into 4 equal parts. We are asked to write the fraction that represent 3 parts of the whole. A whole is divided into 4 equal parts. Write the fraction that represents 3 parts of the whole. We can assume the whole to be anything, but it has to be divided into 4 equal parts. So if you take the whole to be that, if you take the whole to be that, we are going to divide it into 4 equal parts. We have that. So we assume that all the parts are equal. Now we are looking for, what we are looking for is write the fraction that represents 3 equal parts. The whole is already divided into 4 equal parts. So if we are using the idea of shading the equal parts, we are going to say 3 equal parts here. So if we choose to shade this part, and this other part, and this other part, now you will see that 3 parts are what? Are shaded out of the whole. So how do we write the fraction of the 3 parts of the whole? This is simply going to give us how many parts are shaded in this whole. We have 1, 2, 3 parts. So we're going to have 3 all over. The whole is divided into how many equal parts? The whole is divided into 4 equal parts. So 1, 2, 3, 4. So we are going to have 3 fourths. So the answer to this question is going to give us 3 fourths. We proceed to another question. In this one, it's a similar idea like the other one. It reads, a whole is divided into 6 equal parts. Write the fraction that represents 1 part of the whole. A whole is divided into 6 equal parts. I repeat. Write the fraction that represents 1 part of the whole. In this other case, we have a whole, but it is divided into 6 equal parts. And then we are asked to write the fraction of just 1 out of the whole. So again, we are going to go further to try to put this in a pictorial form. We are going to have a whole, and we are going to divide this whole into 6 equal parts. Let's say we have 1, 2, and we divide it like that. Well, it seems not to be very equal, so I would like to take it again. We need a whole, and we are going to divide the whole into 6 equal parts. We have a whole, and we divide it into 6 equal parts. There we have it. We are almost to the answer. Now we have a whole, and we have divided it into 6 equal parts. So can we confirm the parts that we've divided it into? We have 1, 2, 3, 4, 5, 6. What we are asked to write, we are asked to write the fraction that represents 1 part of the whole. So we need only 1 part of that whole. So assuming that we are going to shade the part of the whole, we are going to shade only 1 part and see what is that equal to. You realize that we've divided the whole into 6 equal parts, but 1 out of the 6 parts is shaded. So the answer to this question, how many shaded regions do we have? We have 1 shaded region. So that is going to give us 1 all over. How many parts do we have altogether, or how many parts is the whole divided into? The whole is divided into 6 equal parts. So the answer to this question is going to give us 1/6. That is 1 all over 6. Then we move on to another question. Today we are going to solve many questions, so don't worry. Even the ones we are thinking about right now, we'll solve them. We'll soon get there. Again, we have a similar question just like the other 2 that we've solved so far. A whole is divided into 7 equal parts. In the first question, it was divided into 4 equal parts. In the second question, it was divided into 6 equal parts. But in this case, it is divided into 7 equal parts. We asked, write the fraction that represents 4 equal parts. That is 4 parts out of the whole. Again, I will take the question. A whole is divided into 7 equal parts. Write the fraction that represents 4 parts of the whole. Write the fraction that represents 4 parts of the whole. Let's have a whole, and we divide it into 7 equal parts. We have a whole. We divide it into 7 equal parts. We have 1, 2, 3, 4, 5, 6, and 7. So let's confirm how many equal parts is our whole divided into. We have 1, 2, 3, 4, 5, 6, 7. So we have a whole, and this whole is divided into 7 equal parts. And the question still reads, write the fraction that represents 4 parts of the whole. So again, let's take 4 parts of the whole and set it. Let's set 4 parts here and see what will that equal to. We've set 2 parts. That's the third part, and finally we've set 4 parts. We are almost to the answer. Now we have a whole that is divided into 7 equal parts, and then we have 4 parts out of the 7 equal parts that are shaded. So to answer the question, write the fraction that represents 4 parts of the whole. How many parts in our whole are shaded? We count 1, 2, 3, 4. So 4 parts are shaded. How many equal parts is the whole divided into? We have 1, 2, 3, 4, 5, 6, 7. The whole is divided into 7 equal parts. So the answer to that question is going to give us 4 all over 7. That is 4/7. That is going to be the answer to our third question rather. Then from there we have another one, and it reads, the artist starts painting the wall. There is a certain artist, maybe if you are lucky to be an artist, we are referring to you, started painting the wall. The parts of the wall that look white are not painted. So if you are seeing the diagram right now, you will realize that we have a wall, and the wall is divided into 1, 2, 3, 4, 5, 6. It is divided into 6 equal parts. So the emphasis is the 2 spaces here, the 2 parts that they are seeing in white are not yet painted. But all the other parts are painted because we are seeing colors there. So we have yellow, we have blue, we have orange, and we have green. So all those parts are painted, but there are 2 other parts that are not painted. I'm reading question further. Which statements about the wall are correct? Which statements about the wall are correct? Select the 2 correct statements. Select the 2 correct statements. So we have some statements down here. We want to discuss the statements and see which among them, which out of all of them, 2 of them are correct, and see which ones are correct. Each painted part, that is the first one, the first statement, each painted part is 1/4 of the whole wall. Each painted part is 1/4 of the whole wall. Hello, let's sit back and analyze this. We have a wall. The wall is divided into how many equal parts? 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. It is divided into 6 equal parts. And the first statement is saying each painted part is 1/4 of the whole wall. Well, this statement is not true because the wall is not divided into 4 equal parts, so it cannot be 1/4 of the wall. So the first statement is not true. It's not correct. Then we look at the second statement. The second statement reads, each painted part is 1/6 of the whole wall. Each painted part is 1/6 of the whole wall. Now let's look at the wall again. The wall is divided into how many equal parts? It's divided into 6 equal parts. The wall is divided into 6 equal parts. And each part that is painted is of course 1, because you can see yellow only once. Is painted once. Yellow is painted only once, blue the same thing, orange the same thing, and green as well is all the same thing. So we realize that the second statement that reads, each painted part is 1/6 of the whole wall, is going to be a correct statement. So already we have one of the statements correct. Then we look at the last statement, the third statement rather. It reads, each painted part is 4/4 of the wall. Each painted part is 4/4 of the wall. What this statement simply means is the wall is divided into 4 equal parts and all the 4 parts are shaded. So if you take reference from the wall, it is divided into 6 equal parts and 4 out of those equal parts are painted. So the third statement is not also correct. So far we have only one statement that is correct, which reads, each painted part is 1/6 of the whole wall. We proceed to the next one, that is letter D. The statement reads, the fraction of the wall not yet painted is 1/6. The fraction of the wall not yet painted is 1/6. Let's go back to the wall and confirm. The wall is divided into 6 equal parts. The wall is divided into 6 equal parts. And let's see how many parts are painted and how many parts are not painted. From the diagram, 1, 2, 3, 4, 4 parts are painted. And again, 1, 2, 2 parts are not painted. So let's go back to the question. The question is saying the fraction of the wall not yet painted is 1/6. But from the wall, we know that 2 parts are not painted. So 1/6 cannot be a correct statement in this case. So again, we can conclude that statement D is also not correct. We move to statement E, which reads, the fraction of the wall not yet painted is 2/4. The fraction of the wall not yet painted is 2/4. That is 2 over 4. Well, from this point, looking at it, the wall is divided into 6 equal parts. Having the statement to say the parts that are not yet painted is 2/4 will mean that the wall is divided into 4 equal parts, which is not the case. So obviously from that point we can know that the statement is not true. So it's not correct. Finally, the last one, that is statement F, reads, the fraction of the wall not yet painted is 2/6. The fraction of the wall not yet painted is 2/6. Now let's analyze the question before we go to the wall. This will simply mean that you have a certain wall that is divided into 6 equal parts because the denominator is 6. So the wall is divided into 6 equal parts, and 2 out of those parts are not yet painted. That is what the statement will mean. So let's go back to the wall and see if that is true. What we have is we have a wall. The wall is divided into 6 equal parts. Well, that tallies with what the statement is saying. And also 1, 2, 3, 4, 4 parts are painted and 2 parts are not painted. 2 parts are not painted also tallies with what the statement is claiming for. So it means we have a wall and it's divided into 6 equal parts, and 2 parts among those equal parts are not painted. And this statement claims that the fraction of the wall not yet painted is 2/6. So we can see that the answer is true. The statement is true. 2/6 of the wall is not painted. So far, these two statements that are correct in this case is statement B and statement F, which reads, each painted part is 1/6 of the whole wall, and statement F, the fraction of the wall not yet painted is 2/6. So we move ahead to another question. All right, here we have a word problem. Still remember we are on the fractions, so we are dealing with word problems on the fractions. It says, it reads, Mary cut her ribbon into 4 pieces that are of the same length. The length of one piece of ribbon is what fraction of the length of the ribbon? I will read the question again. Mary cut her ribbon into 4 pieces that are of the same length. The length of one piece of ribbon is what fraction of the length of the ribbon? Mary can be any individual. If you are lucky that your name is Mary, know that we are using your name. We have a ribbon. It can be of any length. But what Mary did is, Mary cut the ribbon into 4 pieces, 4 equal pieces. So let's say this is the ribbon, and that's the length. Starts here and ends there, and is divided into 4 pieces. Let's say Mary decided to do this. Mary have decided to cut the ribbon into 4 pieces. Now what we are asked is the length of one piece of ribbon is what fraction of the length of the ribbon. Only the length from this point to this other point is the length of one piece of ribbon. From this point to this point is the whole length of the ribbon. So each piece represents 1 out of the 4. So that is going to give us 1/4, 1/4, 1/4, 1/4. And the question is, the length of just one piece of ribbon is what fraction of the whole, of the entire ribbon? Well, the question answers itself. Because if you look at it, each length of the pieces of ribbon is 1/4 of the whole ribbon. So the answer to this question is going to give us 1/4. Each piece of ribbon will be 1/4 of the length of the whole ribbon. Then we proceed to another question and see what we have there. Fatu, I wish it was Senabo, but anyways, it's Fatu, so let's Fatu. Fatu rode her bike for 1/5 of a mile on Monday and 2/5 of a mile on Tuesday. How many miles did she rode altogether? I will take the question again. Fatu rode her bike for 1/5 of a mile on Monday and 2/5 of a mile on Tuesday. How many miles did she ride, or did she ride altogether? Fatu has a bicycle. I know she enjoys riding bicycles. So on Monday, she decided to ride the bike 1/5 of a mile. 1/5 is written as 1/5. That's 1/5 of a mile. That was on a Monday. And the next day, on Tuesday, she decided to ride the bike for 2/5 of a mile. 2/5 is written as 2/5. The 1/5 is for the first day, and the 2/5 is for the second day. Now what we are asked is, how many miles did she ride all together? How many miles did she ride all together? Well, all together here is simply telling us that we are going to add the miles that she rode the first day and the miles that she rode for the second day. We add them together. So simply, we are going to add the 2 fractions. We are going to add the 2 fractions. That is, the first day, the distance that she rode, and the second day, the distance that she rode. So we are going to have 1/5 plus 2/5. If you are following the program, in our previous lessons, we've discussed how to add fractions that have the same denominator. We said when you are adding fractions that have the same denominator, you are going to add the numerators and maintain a denominator. And in that lesson, you were told why should you maintain a denominator. So in this case, we just proceed from there. Hence, we are adding, and the fractions, they have the same denominator. We are going to add the numerators. So 1 plus 2 will give us 3 all over. 5 is common in both fractions, so we maintain one of them. So what do we realize? We realize that Fatu rode the bike for the 2 days is 3/5 of a mile. Fatu ride the bike for 3/5 of a mile. So 3/5 answers the question, how many miles did she ride all together? How many miles did she ride all together? The answer is 3/5 miles. 3/5 miles. Let's move to the other question. All right, we have another question, and it reads, Awa added 5/8 of a bag of soil to her garden. Her friend Binta added 11/8 bags of soil to her garden. How much more bags of soil did Binta add than Awa? I'll read the question for the second time. Awa added 5/8 of a bag of soil to her garden. Her friend Binta added 11/8 bags of soil to her garden. How much more bags of soil did Binta add than Awa? So let's analyze the question. There are two friends, that is Awa and Binta, they are friends. And Awa added 5/8 of a bag of soil to her garden. 5/8 is written as 5 all over 8. Five-eighths is written as 5 all over 8. And the friend Binta added 11/8 bags of soil to her garden. So the friend added 11/8, that is 11 all over 8. So Binta added 11/8, we label it as B, and Awa added 5/8. So these two friends, each of them added an amount of soil to the garden. Binta added 11/8 bags of soil to the garden, and Awa added 5/8 of a bag of soil to the garden. The question reads, how much more bags of soil did Binta add than Awa? How much more bags of soil did Binta add than Awa? So in a nutshell, what we are trying to find out is, or what we want to know is how much or what amount of soil did Binta add more than Awa. So in a nutshell, we are going to find the difference between the amount that Binta added with the amount that Awa added. We are going to take the amount that Binta added minus the amount that Awa added. That will give us the amount that Binta added more than Awa. So to do so, we are going to have the amount that Binta added is 11 all over 8 minus the amount that Awa added is 5 all over 8. So when you were doing subtraction of fractions of the same denominator, there is a rule that we came up with. When you have, or when you are subtracting two fractions that have the same denominator, what you do is you subtract the numerators and maintain a denominator. And that was explained in that lesson. So we are going to apply that rule here because they all have the same denominator. So we are going to have the numerator, which is the numerator of the first one is 11 and the numerator of the second one is 5. So we are going to have 11 minus 5 all over. Because they share the same denominator, we are going to maintain 1, which is just 8. So what we have there is 11 minus 5 all over 8. 11 minus 5 will give us what? 11 minus 5 is equal to 6. Then we have the denominator all over 8. (11 minus 5 is equal to 6, and then we have the denominator, which is 8. So the answer to the question is going to be 6 8. 6 8 bags of soil. All right, we have another question. We have 5/8 of a whole circle is colored. 5/8 of a whole circle is colored. The colored part is separated into 2 parts, that is green and blue. The green part is 2/8 of the whole circle. What fraction of the whole is colored blue? I would like to take that again. 5/8 of the whole circle is colored. The colored part is separated into 2 parts, green and blue. The green part is 2/8, that is 2 all over 8 of the whole circle. What fraction of the whole is colored blue? Now what we have here, we have a circle that is divided into 8 equal parts. So out of those 8 equal parts, 5 of them are colored. And further, we realize that 5 of those parts are colored green and blue. We are also told that the parts that are colored green is 2/8 out of the 5/8. Now we are asked what fraction of the whole is colored blue. So we are going to have the total that is colored in the circle is 5/8. And we know that they are colored in 2 colors, that is green and blue. So the part that is colored green is 2/8. The part that is colored green is 2/8. We are asked to find the part that is colored blue. So simply we are going to take the entire part of the circle that is colored minus the part that is colored green. That will give us the part that is colored blue. So we're going to have 5 all over 8 minus 2 all over 8. So I'm just going to bring the division sign there, the subtraction sign rather. So this is going to give us, again, in subtraction, we said if you have the same denominator, you just take the difference of the numerator. So we are going to have 5 minus 2 all over, we bring one denominator, which is 8. That will simply give us 5 minus 2 is equal to 3 all over 8. So simply, the part that is colored blue is 3/8. The part that is colored blue is 3/8. Yes, here we have another question, and it reads, Jalba Kuyate supposed to practice Kora for 3/4 of an hour every day. Today, he has practiced for 1/4 of an hour. What fraction of an hour does he need to practice? I will take the question over again. Jalba Kuyate supposed to practice Kora for 3/4 of an hour every day. Today, he has practiced for 1/4 of an hour. What fraction of an hour does he need to practice? Let's simplify the question. Let's talk about it. We all know Jalba Kuyate, the Kora man. He's supposed to practice Kora for 1/4 of an hour. 1/4 of an hour. Every day he's supposed to do that. 3/4 of an hour every day. So today he has practiced 1/4 of an hour. Today he has practiced 1/4 of an hour. We are asked what fraction of an hour does he need to practice. So we are going to simplify that. Let's say we have this to be 1 hour, and he used to practice 3/4 of an hour. So we can divide the hour into four equal parts. So we are going to have that and that. So normally he practiced from here to here. That is 3/4. That is 1/4, 2/4, 3/4. So he practiced for 3/4. And today what he did is he has practiced for 1/4. He already practiced from this point to this point, just 1/4. We are asked what fraction of an hour does he need to practice in order to meet the number of hours that he practiced for a whole day. So obviously if you look at it, it is also subtraction, because we need to find from this point to the other point. So what we do is we are going to take the total that he practiced every day minus the time that he practiced for today. So that is going to give us the total that he practiced for every day is 3/4. So we are going to have 3 all over 4. We are going to have 3 all over 4 minus the time that he practiced for today is 1/4. We have 1 all over 4. So the time that he used to practice every day is 3/4, and the time that he practiced today is 1/4. So in order to have the time that he will need to practice today, in order to have the complete time that he used to practice every day, we are going to take the difference. So again, we look at it, we have the same denominator. We take the difference of the numerator. So the numerator, we have the first fraction has 3, the second fraction has 1. So we're going to have 3 minus 1 all over. The denominators are the same, you maintain one denominator. So if you take the difference between the numerators, 3 minus 1 is going to give us 2 all over 4. So simply we say he needs 2/4 of an hour to practice in order to have the full time that he used to practice every day. That brings us to the end of the lesson. I thank you all for listening. And again, to do justice to the health department, we'd like to encourage all of you to continue practicing the health precautions about the virus. Continue cleaning your hands every day and use clean water to do that. Also avoid crowd areas and so on. So I thank you all for your kind attention.